Okay, so today let's take a look at some more complicated trig equations. I'm going to go through another linear equation that could be a little complicated, plus some of the quadratic equations with the sine squared theta and the cosine squared theta, because we're going to be running into equations like that pretty soon as well. So we're solving trig equations for theta between 0 and 360, which really means all the possible angles on the unit circle. So let's get started with this. The concept's still going to be the same. We're going to get the cosine function alone with theta, and then we're going to take the inverse of it to find its value, its angle value. That's really what we're looking for in these equations. So step 1, do the opposite. So first we're going to subtract the 1 to both sides. That just goes away. We're left with a negative 1/2 cosine theta equals a 4. Now remember, whenever you're subtracting with fractions, you want a common denominator. So this, we wouldn't write this as a 1. We'd want to rewrite the 1 as a 4 over 4. Why? Because it's still the value of 1, but the 4 is matched. So in your next step here, what you would do is put all the operations on top. So it's a minus 4 all over 4, the common denominator. Now you can clearly see that the 4's on top will cancel out. Got a positive and negative. So you're just left with a negative 1/2 cosine theta equals square root of 2 over 4. So now the next step here is to get rid of this negative 1/2. Well, the inverse of 1/2 is 2, and the opposite of to get this to be a positive, we want to multiply it by a negative. So a negative 2 will cancel out that whole thing, and we're going to do that same thing on the other side as well. So now we're left with just the cosine theta, and over here it's a negative. The whole fraction will be a negative, and the 2 cancels out with the 4 and becomes just square root of 2 over 2, which is good. That's really what we wanted, because we know that square root of 2 over 2 is a value on the unit circle. So where are they negative? Well, cosine is the x-coordinate, so it's on this half of the unit circle. And the negative 1/2 is here at 120. Here's the negative 1/2. And here's another negative 1/2 at 240. So 120 and 240 would be our answers. 120 and 240 are our solutions. Okay, so there you go. Like I said, it's just a linear equation with some fractions and some radicals, so they're a little bit annoying, but they normally work out. They simplify. They all simplify to be the same things a lot of times. It's usually the values on the unit circle. So just a little practice, you'll see that a lot of your steps start repeating themselves. All right, let's take a look at a quadratic. There's two types of quadratics that I want to cover. One where you could square root both sides if it's a monomial square term, and another one where it isn't, and you have to actually factor like you did with normal quadratics and parabolas. So let's take a look at this first one. I've got negative 4 cosine squared theta plus 5 equal 4. Now, the reason I think this one's easier is this, you can spot it right away that there's only one cosine squared term. There's no cosine term, so we really don't have to factor this one. You could set it equal to 0 and factor, but this one's a little bit easier just to get the cosine squared alone, square root both sides, and go from there. So that's what we're going to do here first. First, get the function alone first, this whole function piece. So we're adding 5 to that, subtract 5 to both sides. So negative 4 cosine squared theta equal a negative 1. We want to divide both sides by a negative 4. So cosine squared theta equal a positive 1/4, which is good because you can't square root negative numbers, so we're glad that turned out to be positive. So we will square root both sides of the equation. Remember, when you square root a x squared term, it's plus or minus. So cosine theta is equal to plus or minus. Square root of 1 is 1, and the square root of 4 is 2, so it's a plus or minus 1/2. And so that means the positive 1/2 and the negative 1/2 for the cosine value, which would be on the unit circle, all the 1/2 values for the cosine. So here's a positive 1/2, so 60. Here's a negative 1/2, which is 120. Here's another negative 1/2, which is right here, 240. And positive 1/2, which is 300, right here. 300, positive 1/2. So in that case, you get 4 answers in the interval between 0 and 360. Apologize about the bell. All right, let's take a look at one more. This is the one that's probably going to be the most challenging. You're going to have to factor this like you did quadratics, and I know that many students struggle with factoring. This one is especially challenging because of the coefficient in front, but it's not that bad, as you'll see here in just 1 minute. So we got 2 sine squared theta minus 2 plus 3 sine theta, and that equals a negative 3. Now, this one jumps out at me as being more difficult because of the 2 terms. If you can see the 2 terms, you're never going to be able to get the sine function alone, isolated as a monomial, so you won't be able to square root both sides. So this is one where you're definitely going to have to just set it equal to 0 and factor. Now, there's not a lot of steps in this. There's really only one. Sine squared theta. Well, there's 2. Let's shift this. We want the constants together. So let's put this together. 3 sine theta. And all I did was move that over. This is a negative 2 and a positive 3. So that'll end up being a positive 1 when you bring the negative 3 over. Now the whole thing is equal to 0. Now what we want to do is just set this up. Trial and error for factoring trinomials. This is not a special trinomial or anything like that. So the first term will be the sine theta. Now the only thing you can multiply that to get a 2 sine theta is a 1 sine theta. So sine theta. Those are the only 2 options to make that product in the front. So that's pretty easy. And the only 2 options to make this product in the back is a positive 1 and a positive 1. You could do negative 1 and negative 1 and still get a positive 1, but these all add up. We have to add up the 3 positive signs in the middle. So those are the only 2 options. So as you can see, if you put a little thought into that, there's really not a lot of options in the factoring that, so it's not that big of a deal. Now, we're going to do the same thing here. We're going to set each factor equal to 0, just like we did with regular. Okay, so continuing on, remember what I said here. What we were going to do is set each factor equal to 0. So this 2 sine theta plus 1 equals 0. And the sine theta plus 1 equals 0. And now you have 2 small linear equations, and you just solve them by doing that. Subtract 1 from both sides. So 2 sine theta equal negative 1 divided by the 2, and sine theta equal negative 1/2. So what angles have a sine of negative 1/2? Looking at the unit circle, it looks like you're going to have a negative 1/2 here at 330 and another negative 1/2 here at 210. So this part is 210 and 330. Now let's see what the other piece of the other factor produces. Subtract a 1 to both sides. So sine theta equal negative 1. Well, on the unit circle, there's only one value of negative 1 for the y value, and that's at 270. So 270 would also be an answer. So in that case, there's only 3 answers to that equation. Alright, so that covers some more complicated trig equations. I hope that helps out. Feel free to post any of your comments below, and thanks for watching.